Imagine that the completion of our universe might be the beginning of the next one, perhaps one that is completely unique, yet fundamentally similar to our own. Hypotheses of the multiverse are not new to humanity or astronomy. However, evidence for this theory is emerging. The James Webb Space Telescope has recently delivered the first image of another universe. Since the earliest days of recorded history, people have looked up at the stars and wondered about the sun, the moon, and the stars. For the earliest people, the sun and the moon were openings above, through which light entered a world they imagined as a flat disk. Over thousands of years, our species discovered that we live on a sphere that rotates and orbits a star, which is just one among billions of other stars and planets. We are a small part of a vast universe, and possibly a much greater multiverse. Despite having a strong understanding for close to a century, we still have little knowledge of space. Scientists are continuously discovering new properties in the universe. They find answers to old questions, but many mysteries still remain. Not so long ago, we didn't have any idea who created the universe or why. We didn't know whether the universe had an end or if it was infinite. With our best telescopes, we have so far been able to see around 13.3 billion light-years away. When we look, we are always looking back in time, as the light that telescopes like Hubble detect has traveled through space to reach us. We see the image as it existed when the light started its journey to us. This glimpse into the past is fascinating. Scientists had the opportunity to study almost to the beginning of the universe, or so they thought, until James Webb, the new space telescope from NASA, the Canadian Space Agency, and the European Space Agency, ESA, began its operations in the summer of 2022. Even the first image from the telescope provided tantalizing evidence that sparked heated discussions among researchers. Specifically, there are 6 galaxies that should have existed around the dawn of humanity, for which there is no clear reason. Structures like glass Z13 existed 250 to 350 million years after the Big Bang, and that is theoretically astonishing. At this point, there should have been only a few stars slowly coming together to form entire galaxies, and a few billion years would have been required. What does this mean? Is the theory of the Big Bang wrong? Or is there a completely novel explanation? There could be one. We might actually be looking at another universe over here. The image of the structure cluster MAX J0647+75 reveals a breathtaking view of an array of structures, like massive pearls glittering in the vastness of space. What truly excites scientists about this image is not just its beauty, but the fact that the same region of the universe was previously imaged 10 years earlier by the Hubble Space Telescope. Yet, the quality of the image was not nearly as significant, and the old and faint objects in the background could not be discerned. It was only clear that they existed, and that was strange enough. The gravitational lensing effect, where small and distant objects in the background are magnified by objects in the foreground, let astronomers know that these faint sources of light were old, very old indeed. James Webb then revealed surprising new details. Thanks to the triple lensing effect, the universe is so old, so magnificent, and so deeply structured that our Milky Way seems quite ordinary in comparison. Today, scientists are particularly baffled by the data on galaxies. If the interpretations are correct, these galaxies have produced far more stars than our galaxy, challenging all the principles of cosmology. Perhaps scientists have built every cosmological model around an assumption that now appears to be wrong. This revelation is a shock for those who believed in the existence of a single universe and assumed that everything within this universe could be explained with the principles of Einstein's theory of relativity. Meanwhile, different branches of physics have long suggested that it's much more plausible for us to live in a universe that is just one of many, with multiple other realms or universes that could exist beside, or even within our own. These systems could challenge our current concepts, as they belong to an entirely different universe and exist within a completely different time frame. One of the first newly discovered structures was glass Z12. Galaxies are usually named after the observation systems through which they are found. Glass refers to gravitational lensing accurate shift survey, and Z12 denotes the value of the redshift. Each observation team uses a slightly different naming scheme. The redshift value of a newly discovered galaxy is not arbitrary. Galaxies can also receive simple numerical designations. To laypeople, Z12 may sound normal, but astronomers held their breath with this designation. This value implies the structure existed 300 to 400 million years after the Big Bang, so it's indeed very old. According to current cosmological theories, this is an incomprehensible discovery. The revelation of glass Z12 was already celebrated as a sensation in the academic community. However, even older and more fascinating structures followed. The universe candidate CRS 93316 seems to top all the anomalies. This object is so old that it existed only 250 million years after the Big Bang. Yet this object presents another oddity. Assessments of redshift yielded two incredibly different results. At one point, the object showed a redshift of 16.7 Z, indicating extreme age. Then, assessments of nearby objects to CRS 93316 were taken, and based on those, the galaxy showed a completely different redshift. The galaxy appeared to exist in two places, and twice, at the same time. Scientists eagerly refer to the structure as Schrödinger's universe, inspired by the famous quantum physicist Erwin Schrödinger, who demonstrated that at the quantum level, more than one reality can exist simultaneously. According to these theories, it's not only possible to have two universes. There could be potentially countless more in different and unfathomable design. Specialists snaring with these assessment results could, in any case, need to take confidence in an assessment slip-up or even question whether these spots of light are universes by any means. While the spectroscopy assessment to confirm the redshift is still advancing, further data assessment from James Webb's IR camera system has now completely ruled out the possibility of it being a young star or a hidden dynamic boundless focus. We should contemplate that the revelation of CRS 93316 was only the beginning of what is possible. NASA has suggested that the James Webb Space Telescope might actually perceive universes with a redshift greater than 20. These universes would have existed only 200 million years after the Big Bang. Or perhaps the telescope is looking much further into bits of our universe, which could demand that we have encountered a breaking point of existence unrelated to the Big Bang. Right now, we can no longer speak about the beginning of mankind, the universe, or the time after the Big Bang. Rather, we change the terminology and refer to it as the edge of the observable universe. There lies one particularly fascinating source of light that shows an especially high redshift value in our images. This shows that the galaxy 2744 Y1 is, without a doubt, a universe whose light has traveled in excess of 13 billion years to reach us. A group of investigators has merged the best telescopes on the planet, the Spitzer telescope, ALMA, and Hubble, to capture a new image of this astonishing framework. By gathering data from different frequencies of light and merging them into one picture, not only is the age and distance of this galaxy captivating, but the speed of star formation also surpasses anything previously thought to be possible in physics. Despite being a few times more compact than our Milky Way, the galaxy 2744 Y1 produces stars at a rate several times faster than that of the Milky Way, which is astonishing for a galaxy in a young universe. The observable universe currently has a range of 46.1 billion light-years. Beyond that, there is likely considerably more. The better our instruments become, the further and more detailed our observations can reach. James Webb is theoretically capable of observing back 13.6 billion years. If the Big Bang happened 13.8 billion years ago, there would eventually be a cutoff to our insights, as a few hundred years after the Big Bang, the universe would have been completely dark. The first stars are believed to have formed only about 380,000 years later. If astronomers continue to find significantly older cosmic frameworks, it will inevitably show that all past cosmological assumptions were flawed. Right now, specialists at NASA are obtaining initial insights with the new telescope, which have already been astonishing. However, we know that time generally brings new revelations, and in a few years, experts could truly extract even more from the telescope's capabilities. Perhaps we could finally see what truly happened at the alleged beginning of time. Yet, while the theory of the Big Bang seemed plausible for a time, there was no evidence to support its accuracy. With the rise of quantum physics, it became fundamentally more plausible that the universe is an incredibly diverse and potentially complex place. Models of the bubble universe or pocket universe suggest that our universe is encased in an immense bubble and shares space with a multitude of other bubbles of varying sizes. The pocket universe posits that within a universe, there are various regions where similar yet unique conditions could exist. These pockets could provide access to different perspectives or corners of the universe where different laws apply. There is also a significant amount of evidence and clues for these hypotheses, just as there are for the Big Bang theory. The theories of the Big Bang and the principles of Einstein's physics were established long before the theory of quantum physics. In the future, the integration of these models could lead to a deeper understanding of our universe and the multiverse. If this turns out to be true, then we might be living in a bubble universe surrounded by many other bubbles. Or there could be an endless number of universes, each with its own set of physical laws. This would imply a level of complexity that goes far beyond our current comprehension of the universe and our place within it. As we continue to explore and uncover new data, the possibility of finding alternative universes and perspectives becomes increasingly possible, perhaps reshaping our understanding. We may interpret reality itself in a new light. Diving deeper into the implications of these new cosmic discoveries, we need to explore the greater questions they raise about our universe and our place within it. Perhaps one of the key questions is whether the universe we see exists as it is, or if our observations merely reveal a much larger and more astounding framework. The likelihood of a multiverse, where potentially vast universes exist beyond our own, has gained some solid traction in both theoretical physics and cosmology. If the new discoveries made by the James Webb Space Telescope suggest the presence of universes that contradict current understanding, it could indicate that our universe is just one piece of a much more intricate and boundless tapestry. The multiverse theory itself comes in various forms, each with different consequences for how we might interpret reality. One is the inflationary multiverse theory, which suggests that during the early moments of the Big Bang, different regions of space expanded at different rates. This uneven expansion could have led to the formation of distinct bubble universes, each with its own set of physical laws and conditions, constants. Assuming that this speculation holds, the universe we see might be just a single air pocket in a gigantic, different froth. Another enchanting thought is the possibility of a cyclic universe. This speculation suggests that the universe goes through an eternal pattern of creation, evolution, withdrawal, and revival. As demonstrated by this model, the universe as we understand it might be the consequence of a past universe collapsing in on itself and thereafter returning in a tremendous explosion-like event. This cycle could, in fact, go on perpetually, providing one way to suggest that our universe cycles through a perpetual series of incalculable restorations. The discovery of incredibly old systems, like GLASS Z12 and CRS 93316, poses critical challenges to our current perception of cosmic evolution. These discoveries suggest that there might have been processes occurring in the early universe that we do not yet fully comprehend. If massive systems could form and organize themselves so quickly after the Big Bang, it implies that our models of galactic development and arrangement might require fundamental revisions. This revelation could lead to new theories about how galaxies and other massive structures develop and interact over time. Additionally, the possibility of encountering anomalies that seem to conflict with standard models of physical science opens the door for a reassessment of key principles. For example, the presence of universes with properties that challenge how we interpret dark matter, dark energy, and the behavior of light could at some point require an update of the standard model of particle physics. This could also lead to a reconsideration of Einstein's theory of relativity and how it applies on the most extreme scales. As we continue to push the boundaries of our observational limits, the role of future space missions and advanced telescopes will be essential. Instruments that are fundamentally more powerful than the James Webb Space Telescope will be needed to probe further into the universe and potentially perceive much more distant or faint objects. These advancements will help refine our understanding of the universe's history and structure, and may provide further insights into the true nature of the universe. The philosophical and existential implications of these discoveries are immense. If our universe is part of a multiverse, or if there are realms beyond our current observational limits, it challenges our very understanding of existence. This could impact not only scientific theories, but also our philosophical and spiritual perspectives on life, consciousness, and the concept of reality. As we unravel more about the universe, we might find ourselves re-examining fundamental questions about the meaning and purpose of our existence. In summary, the new insights gained from the James Webb Space Telescope and other high-level observational instruments are expanding our knowledge of the universe in ways we had not expected. These revelations are not simply adding new pieces to the infinite puzzle, but are fundamentally reshaping our understanding of the cosmos. As we continue to explore and learn, we stand at the brink of potentially groundbreaking discoveries that could alter our perception of reality itself. The journey to understanding the true nature of the universe is far from over, and each new revelation brings us one step closer to unraveling the mysteries of existence. The idea that the universe's end might mark the beginning of another has intrigued thinkers for centuries. The multiverse hypothesis suggests that our universe might be only one of countless others, a notion that has gained traction with recent discoveries. The James Webb Space Telescope, JWST, launched in 2021, is providing new insights that challenge our comprehension of cosmology. For centuries, humans have gazed at the stars, evolving from ancient beliefs of a flat Earth with lights above to a more complex understanding of a spherical planet orbiting a star within a vast universe filled with countless galaxies. Despite over a century of astronomical advancements, our understanding of the universe remains limited. The JWST has recently captured images of ancient galaxies, sparking discussions about their implications for the Big Bang theory. The Big Bang is thought to be the universe's origin, but recent findings suggest galaxies like Glass Z13 existed far sooner than previously believed, just 250 to 350 million years post-Big Bang. This raises questions about the validity of the Big Bang theory itself. The JWST has produced images of galaxy clusters, revealing structures that were harder to interpret with earlier telescopes. Gravitational lensing has allowed scientists to observe distant galaxies in unprecedented detail, with some showing star formation rates much higher than those in our Milky Way. New discoveries, such as Glass Z12 and the exceptionally ancient CRS 93316, challenge the very foundations of our cosmological models. CRS 93316, showing signs of existing in two distinct redshift states, suggests the possibility of multiple realities coexisting. This leads to the concept of a multiverse, where distinct physical laws could apply. Ongoing research with the JWST opens up the potential to discover galaxies with even greater redshift values, suggesting that our understanding of cosmic history may require revision. If these ancient galaxies formed sooner than speculated, it could indicate that processes we don't fully grasp were operating in the early universe. The implications of these findings extend into theoretical physics, prompting the need to rethink current models, including the Big Bang hypothesis and Einstein's theories. The possibility of cyclic universes and inflationary multiverse theories presents the idea that our universe could be just one of many, each with unique characteristics and histories. As we advance our observational technology, including future telescopes, we can anticipate even deeper insights into the universe. These advancements not only reshape our scientific knowledge, but also provoke philosophical questions about our existence, purpose, and the nature of reality itself. With each new discovery, we move closer to uncovering the profound mysteries that lie beyond our current understanding of the universe.